How about now? Is this working? Test 1, 2. Okay. Let's see. Ahmad, is it working now? Thanks for letting me know. Is it working now? I'm seeing some items on my mixer, so I have a reason to think that it is working now, but I would love confirmation. Yes, works perfectly. Okay, great. All right. Yeah, so how do I get the sum? The sum is, call this cur sum, and that's going to equal the left of numbers plus the right of numbers. What do I want to do? I want to compare this sum to the target. If cur sum is less than target, we'll increment. Else if cur sum, I'm not having the IntelliSense. When you go from like VS Code into the Leetcode IDE without IntelliSense, it's so jarring to me. Cur sum, else if it's greater than target, we will decrement. I don't know if I spelled that correctly, but it's fine. Else found match return. Return one indexed form. And I think we had returned them as a list. Yeah, I can see in the type signature we'll return them as a list. So I'll go left plus 1, right plus 1. Ahmad, thanks again for giving me the heads up on that. I would have gone a whole hour with no audio, man. Okay, and so when I decrement, what am I doing? I have my left and right pointer. It's sorted non-decreasing, so right is guaranteed to be the higher value. So to decrement my sum, I'll take that right pointer and move it to the left. So I'll go right minus equals 1 is going to take that right pointer and move it to the left. And then here we will do the reciprocal, which is left plus equals 1. And there's one down. Now let's go for three-sum. The point of the Leetcode Kata is that one builds on another, so these problems are intentionally similar. So let's read through, and this is a good question. I got asked this in my C1 final. Yeah, I mean, it's a good junior question. It's really so I'm a staff engineer, so for me this is not even a warm-up level question for me. But it's still good to do this. One of the mistakes I see for senior plus engineers like myself is if they want to get back on the job search, they'll dive in and they'll go, oh, at my level, I need to be doing mediums and hards. And they'll dive right into that. And they can get demotivated because they'll realize I'm hitting a wall and I'm not even getting those basics. And so one of the things that we'll talk about is the smarter ones we'll talk about, we need to go back to the basics, remind ourselves of those fundamentals. And then this gets a little confusing when we're talking to early career folks because someone who's really a junior, when they do the fundamentals, they need to study different things than sometimes what we mean when we say fundamentals. So that word fundamentals, if someone uses that word, they're not wrong, but clarify what they mean because it actually means different things in different contexts. That's a tip, quick tip. I've seen this before laterally, right? Yeah, that's it. That's it. You got it, man. Okay. Fundamentals are the most important. I have about 300 solved. Can now do mediums comfortably. Rock on, bro. Right. Now you're cooking, bro. Okay, let's read three-sum. So in this form, which is problem number 15, expression of threesome, there's different ways to do it. You can have no sort, but this is the expression given in problem 15. Given an array of integer nums, return all the triplets. And notice here I'm doing I of nums, j of nums, k of nums. So this is the triplet of values. This is no longer indexes like we did in the other case. I, j, k need to be distinct. So the values don't need to be distinct. The indices need to be distinct, right? Pay attention to the small details. Can't tell you how many times I've kicked myself because one of these small details can really throw you off. Pratik, welcome in, welcome in. By the way, I think Pratik suggested on LinkedIn earlier that we should just do a general catch-up stream, and I'm totally down for that. So if y'all just want to throw random questions in, we can pivot. I'm working on these Leetcode problems, but it's like not a big deal. So let me know if you have a question or, you know, what you've been up to lately. Would love to hear about it. And after this stream, I do plan to do some open source coding as well. So follow the channel and stick around. I see we have some friends over on TikTok. Hope you'll follow around for that. Okay, we look at a few examples here. Look at example 1, -1, 012, -1 again. So they are out of order. That's important to note. Whenever we look through these problems, one of the things we're going to want to optimize runtime complexity, space complexity, and one of the things we want to look for is it pre-sorted or not. And so we're seeing it's not pre-sorted. And then notice I have that -1 twice. I have that -1 twice, but that's okay. Because we can see in example 3, we return multiple zeros. So we can return the same value, just not the same index. And then example 2 is also interesting. There's no such triplet, therefore return an empty list. That's another interesting wrinkle. So here I'll say find triplet, and then I'll eventually return an empty list. Could not find triplet. Okay? Hopefully that's everything I need to do for example 2. And then what I want to do here is think about my approach. And my approach is what time and space complexity should I shoot for? So in the limit, I need to search every element at least once. At least once. So I don't think I can do better than O of n. In fact, reflecting on two-sum, to find a two-sum target, I have to go O of n, don't I? And then given that two-sum target, I can add a complement and get to 0. That'll give me my three-sum. So there's O of n on the two-sum. O of n is optimal time complexity for two-sum. I need to wrap two-sum with an O of n iterator across complements. So optimal time, or maybe not optimal, but I'll say target time complexity. Target optimal time complexity is, what is it, chat? O of n squared. It's going to be O of n squared. And the interesting thing about O of n squared is, so I can sort without binding, let's see, without, what do you call it in chemistry? Like a limiting factor. Let's just say without worsening time complexity. Because sort is, what is it? O n log n. How many of you solved? I don't know, maybe 40? Let's see. Oh, did I start a new account? This is just since 2020. What? I might have multiple accounts. All right, let me sign out, I guess. I'll put this on my clipboard. I like signed in with the wrong email or something. I'm going to open up my other Chrome and check my password manager for Leetcode. Does it not save your progress if you drop premium? I dropped premium. No, it says it's this one. That actually bums me out. Hey, can you... This is not affecting everyone, right? Can you go check your Leetcode and did your progress get wiped? Can I search the discussion forums for Vanderveer? Oh, what do I mean cite Google? I meant Leetcode. I don't know. It's saying I've solved 3, but I've definitely solved more than 3. Let me check my email if I have. Yeah, okay. I was using a different email address. Y'all can email me here. I'm not worried about showing this email on stream. See if I can refresh my stuff real quick. It has to go through email forwarding, so that might take a little bit. Whatever. I'll go with this one for now. So whatever. I think I've solved around 50. I'm not the guy who's solved like hundreds and hundreds of problems. I just got back. How much have you solved all time? I think it's in your progress. No, it's not there for me because I switched my emails. That's what I was saying. It says I've done 3, which is just not right. See, it says I've done 3. I think I've done around 50. Okay, let's get back to the actual problem, eh? So here's 3 sum. Yeah, here's my progress. Okay. So that is the time complexity. What about the space complexity? Well, I can just do, so space complexity, space is O of 1 because it's just pointers. Cool. So nums is, I remember I watched your streams back then. Yeah, I'll try to get back on that same account so we can do the whole flex. I don't think it's that big of a deal, but I have to head off. Keep killing it, bro. Yeah, see you, man. Thanks for being here. So is it sort or sorted? I don't know. So now I have sorted, and then I'll go, I'll call this far left, and that's going to be 0. And then I'll say while far left is less than the length of nums. I want to call to sum. I want to fast forward duplicates, and then potentially return, possibly return. So the complement is the opposite of whatever number I'm on. So this will be the far left index of nums. That's it. That is the complement. And then so I will say self.toSum. And what do we want to give it? We want to give it nums. We want to give it the current index. We want to give it the complement. Is that everything I need? we want to, oh, no, there could be multiple results, right? So I'll say results is a set for auto deduplication of tuples. And so we'll place tuples into there. So far left, left, and right will all be included in a tuple. So we actually won't return here. It'll be possibly add. But that I don't need to note that because that'll go inside the two-sum. So here I just need to fast forward duplicates. And that'll ultimately return the results, or I can do an empty list. If the result is falsy, it'll fall back to an empty list. Okay, and so then here's def two-sum. Since we're in a class, I need to pass self. That's a Python thing, don't worry about it. And then what are my arguments? I have nums, I have far left, and I have, so in the two-sum context, this will be the target. And that's it. And then left is going to be far left plus 1 because I need the IJK to be distinct. So I won't retest the same index. And then right is still going to be the length of nums minus 1. Okay? And then here it's just the same two-sum we already did. So while left is less than right, if above, else if below, else found target, but here we will append results with sorted. We want to sort the values, right? 011, minus 1, minus 1, 2. I'm looking back at the examples. Yeah, the values are always sorted. But I don't need to sort them because it's always going to be in order. So here, and then I do want to fast forward duplicates. I don't even need to do anything down there. I can just exit the function when this loop is complete. So here, oh, and I need to pass in results in this case. Yeah, that feels like everything I need to pass in. Okay, so here's results. And so results dot add, and then here I'll make the tuple of far left, left, right. Those are the indices. I want to do the values, right? So let me pick them off nums. Because nums is sorted, these should always be in order. Parentheses syntax because it's a tuple. Tuples are hashable, so the set can deduplicate them because it contains unique hashes. And so now I don't need to check if I've already added it. I can just place it in the set and keep going. And how do we know if it's a duplicate? So far left is going to remain constant for every call to two-sum. Therefore, I could pick left or right. As long as one is constant, the other will deterministically be constant. And so they're just going to be duplicate iterations. Does that make sense? So I'll arbitrarily just pick left just to keep with this mental model of moving left to right for simplicity. But in theory, you could perturb either. So I'll do a nested while here. So while nums left is equal to, what is it equal to? Cur left. And left is less than right. So we're going to repeat the boundary condition so we don't go out of range. In this case, I want to go left plus plus, right, and cur left is going to equal left off of nums. So that will move the pointer, and then we'll check the next iteration. I think that's right. There might be some typo there, but I think that's right. So I need to go get cur left. Cur left is the left of nums. Cur right is the right of nums, and cur sum is cur left plus cur right. Okay? And so what does it mean to be above? This means that the current sum is greater than target, and I want to reduce the current sum so they'll be equal, so I want to move my right pointer to the left. So right minus equals 1, here left plus equals 1. Is this making sense? Let me know. Cool. I think we're good on the two-sum implementation, if I'm not mistaken. Okay. So by this time, for a given far left value, we will have appended the result if it exists. And now I need to fast forward on far left. So I can kind of copy this template over here. The difference is that I'll be looking at far left instead of left. So far left plus plus, and then complement is equal to, do I need to reset the complement here? I don't think I need to, I don't think I need to reset the complement, do I? I don't think so. We'll see. So instead of left, we're going to say, I'm going to take the nums far left, but actually what I want to compare is the complement, because the cache value that I have here is the complement. I'll just reuse that. So as long as the complement is the same, then I want to move to the next far left without rerunning two-sum. That's how I'm saving some cycles. But my boundary condition is different here. So let's repeat this boundary condition so we don't go out of range. See how this works. Okay, so I did something wrong here. Oh, is that JavaScript? You can't do that in Python. So we'll go plus equals 1. Okay, name sort. Did you mean square root? No. I think I meant sorted. I think I can also just do like nums.sort, right? I think those are equivalent. Does it let me get away with that? Okay. And I can print this really quick. Yeah, so that sorted it. That sorted it. So nums is out of order, and then the printed nums is in order. Okay, so what is this index out of range? While, oh, okay, I need to reverse these. Let's only check, let's only pick that index out of nums after the boundary condition is safe. So I probably also have that issue over here. Just reversing, do the boundary check before the cache evaluation. -1, -1, 2. That's a correct result. It's not a valid value for the expected return type. Okay. So it doesn't like that I'm using a set. Can I just do this? Probably not, but that'll be super convenient if I can just do that. So I got -1, -1, 2, okay? But I didn't get -101. Bummer, why did I miss that? So my far left is -1. So this is a singular call to toSum that has some issue with it. So there's some issue in my toSum. Some issue in my toSum. While left is less than right, seems correct to me. We get the current left. Maybe, I think it's this part. I think resetting that is potentially missing. Yeah, okay. So once I cache this current left, I don't want to update current left in the fast forward logic. That could create some issues. Okay. Cool. 2 down. Let's do another one. We're at the 30-minute mark. We're actually running slow. I feel like I'm running slow. That's okay. I haven't done this in a while. Longest substring without repeating characters. Let's go. So we're given S. It's a string, and then we want to return some integer. And so we want to find the longest substring. So longest substring of S could be S. Could just be the whole thing. So min time complexity must be O of S. AKA O of N. All right, so that's going to be the time complexity that we'll go for. And then what about the space complexity? I want to find the length of the longest substring without repeating characters. So I need to collect the characters that I've seen, which in the limit could also be S. Need to collect seen characters, which could also be up to O of S minus 1. We're going to be doing this check like, did I see it? Did I see it? At every character, did I see the previous character? So at the last character, you technically don't cache all of O of S. You'll cache up to O of S minus 1 because at the last character, there's no need to like cache it further. So it's O of S minus 1, but then that is asymptotically equivalent to O of S, aka O of N. Does that make sense? So that's going to be the space complexity. All right, and so we need some kind of scene. This could be a set, this could be a hash map, whatever. So there could be some other data structure there, but I'm just marking a note. That's not a final implementation. I'm just marking a note that I need a scene cache of some kind. So let's look at these examples. And do I want to, I just need to have the length. I don't need to have the actual substring itself. So I'll have a max len, and I'll initialize that to 0. I guess S could be an empty string, huh? Yeah, it'll never be negative. So I'll start it with 0, and then every time I get a long one, every time I get any substring, actually, every time I get any valid substring, I'll evaluate the length. So to do it, so I want to iterate on chars of S. Then I want to validate cur substring. Then I want to check length cur substring. And then I want to max len equals the max of max len, whatever it already is. Are we beating the record? Am I beating the record? So I'm going to take the max of whatever it previously was, and then the length of cur substring. This will go inside of some loop across the characters for something. Okay? And then I will eventually return the max length. So So that's going to be kind of the high-level structure of this algorithm. Let's reread the examples one more time and the constraints. Are there any edge cases we're missing? Interesting to note that S consists of English letters, digits, symbols, and spaces. So you could say that there's like a finite ASCII map. There's like a finite kind of characters, which is an interesting thing. And it doesn't really impact my algorithm though. It's still going to be O of n. Okay, and then there's some length constraint, whatever, some huge crazy number, 5, 10 to the 4th, okay. Why 5? That seems weird. So I could have a bunch of B's, and if it's a bunch of B's, then we only get to 1, because every time I hit a scene character, I need to reset. ABC, 1, 2, 3. And then ABCB, that does count as a repeated character. So it will reset on the second B. ABCB, that's our trigger condition. It's not that they need to be adjacent. Oh, so then it'd be ABCA. We'll reset on that A, right? So what I should do, yeah, I'll do a sliding window basically. So I'll do a left to right sliding window and I'll drop left if right is seen. So when I run into a new character, boom, a new one. I don't want to like skip the right hand forward, then I'll have like this patchy string that's not really a substring. I don't want to move right and then move my right hand back, because then on the next iteration I'll just be making an infinite loop. What I'd like to do is when I move that right hand, oh no, I've already seen this character. Let me move the left until, so I might need to move it multiple spaces. Move it until I have a valid substring. Drop left if right is seen until right is unseen. So we'll purge it out of the scene map. And it can be a set. It can be a set. So with a hash map, with a dictionary, there's like a key value pair, but I have no need to be aware of the value. I just need the binary indication of whether a character has been seen. So this can be a set. So this is the appropriate, because I don't need a KV pair, just a key set. Okay, you could use a dictionary, but it's just sort of unnecessary. And I think we have everything I need. So let's go ahead. So let's do this sliding window. Do I want to initialize a left out here, or can I use like one of the iterators here for left in, or like for cur, char, and s? So this will be my right hand. So that's the cur char is the right hand of the sliding window. Do I need to track left? I really don't. I just need that scene set and the length. I don't actually need a pointer to left. Cool. So I think we're good on that. So the first thing I want to do is do this validation logic. So if cur char in scene this bad. So what do we do? The current character has been seen. I want to purge left. Ooh, okay. Then I do need a left index, don't I? Yeah, okay. I do need a left index. So left is 0. Thora, man, I wish I could reach this level of coming up with intuition like yours. Just do the kata. It's not because I'm a genius that's like thinking on the fly. It's because this feels familiar. You see what I'm saying? It feels familiar. I've done this problem many times. This is not my first time seeing the problem. So do the kata. It's going to be rough. I don't know, the first 1, 2, 3 times, and then after that you start to go, oh, I know how this goes. I know how this goes. That's the whole secret. That's all there is to it. Again, here's the Latterly Leetcode Kata, blog article number, what is it, 1 or 2 or something? Blog article number 3. And there's the Leetcode Kata, and then you can do the expanded kata if you want to. You want to do some binary tree stuff. Don't be intimidated. Balanced binary tree. Ooh, that sounds scary. It's an easy problem. It's an easy problem. You just got to do it a few times, and then you'll go, oh, like this is fine. Path sum 3 is probably harder, right? Well, even this one's a medium. Fine. Don't be intimidated. Just get in there. You do 1 or 2 problems a day. Do that for a couple months. If you're the only time it's really painful is if like you're in a hurry, right? If you're like, man, I need to get good at like 10 different patterns in 2 weeks. That's tough. That's tough. So the secret sauce is to give yourself more time. Okay, where were we? All right. If the current character is in scene, then I want to purge left. So left is here at the 0. And so what I'll need to do is scene dot remove. I think it's remove s left of s. So we'll remove the left of s, and then we will increment left. So now in the ABCA case, I've purged this A and I've moved my left pointer up to the B. And we're clear to proceed. We're clear to proceed. And so now what I want to do is make sure that I remember that I have seen A. Okay, so we purge to the left. We're using a sliding window. One second, I'll get to your comment. Let me finish up this train of thought. We're going to check length on the current substring. That's already included in line 20, so I can drop all those comments. So what I want to do here is remember that I have seen the current character, which is the right hand. Because if I've removed it from the set, from the point of view of the scene data structure, it's as if I've never seen that character, even though in fact I have. So we want to make sure after we're done purging it, we reinsert it for the next iteration. Because you might get multiple B's in a row. That's the reason for doing that. Okay. Can you repeat the last 2 to 3 sentences again? If I recall the point in the conversation, the two or three sentences, I'll go with 2. One would be, the secret sauce is give yourself time. Just try to do 1 or 2 problems a day, not 7 days a week, right? 3, 4, 5 days a week. Do 1 or 2 a day for a month or 2, and boom, now you have gotten to that 10 patterns, and it's not that stressful. And you can time box yourself. So we're time boxing this stream. I won't be going over an hour. And similarly, you can time box yourself on each problem. I would time box the problem down to probably like 20 or 30 minutes. So you can do 2 or 3 problems in an hour. And don't feel bad if you don't get it. Like if it's an easy problem, you might get it on the first try within 20 or 30 minutes. But very often, you're not going to get it the first try in 20 or 30 minutes. If you stuck with it for an hour, you might get it. And then sometimes, even if it's easy, you might not get it on the first try. That's okay. Don't feel bad. Just look at the solution, try to understand the solution, and then come back the next day. And I'll say stick with that time box of 20 minutes, not 30. Work on it for 20 minutes, look at the solution, and then spend 10 minutes trying to understand the solution. Like actually understand it. Read through multiple solutions, maybe look at it in a couple coding languages. You go over here to the solutions tab. Don't just take the first one you see. Like look at a few of them so that you can get a deeper understanding of, first of all, what's going on, and then second of all, how would you write it your way? Writing it your way is going to help you reinforce neurally. You're going to like understand how to do it better. Because sometimes trying to do things the way that other people did it, even if it's very often it's just a matter of the variable naming. that you're like, what did that guy say? Oh, no. Put it in your own words and then write it down in your own words. It's going to be easier for you to remember. And even in an interview setting, if you fumble and if you can't get the full working solution, at least you're going to be able to express some portion of the solution in your own words, which looks much better to the interviewer compared to the situation where instead of you're like, this is the limit of my words and I can't see how to go further. That actually looks better than me struggling to remember what someone else told me the answer was. That's a bad look. Because in that case, how it looks to the interviewer is like, they don't have a clue what's going on, and they're just trying to memorize what other people have said, and they can't even do that. And that's a bad look. Make sense? So there's no problem with memorization. Actually, memorization, like dirty secrets of Leetcode, memorization is one of the major keys. So I think that understanding the patterns deeply is on the other side of memorizing a few problems. If you memorize a few problems, then you can abstract up to the patterns. I think it's backwards to say memorize the pattern, but don't memorize any particular solutions. I think that's very backwards. Does that make sense? Because for you to deeply understand the abstract, you want to understand the concrete references. Otherwise, you might be one of these like people who understands the theory, but you can't code. Like, let me see a concrete implementation of what you're talking about. It's a much better look. Even if you can't get all the way to done, it's a much better look than struggling to remember what somebody else said. And you don't even know why they named the variable that way. Knowing the why is deeply neurally reinforcing. Knowing the reasons why, because then you can always backtrack to the logic. And then you can come up with another name if you understand the reasons why. So the name should be a representation of what it means to you, and then by writing that down and by saying it, it'll reinforce the concept for you. Trying to memorize other people's variable names, particularly if they give one of these like classic Leetcode one-letter variable names that doesn't have semantic meaning, or if they give it a meaning that's counterintuitive to you, if they give it a name that's counterintuitive to you, it's going to actually make it harder for you to learn. All right, so I did this stuff, right? Did I get the whole thing? I'm not sure. Let me double check. So let's walk through a test case. Pew, 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 Q. So I got the P, I'm coming in with the P. Current letter is a P. Is the P in the scene? No, it's initialized to empty. So it's not there. So we bypass the if block. Let me add the P here. Now it is seen. My current max length is 1. Now I'm on to the W. It's not seen. Now seen is PW. Max length is 2. Now I get the second W. Oh, I've already seen a W. I've already seen a W. So let me move my pointer from the 0 index on the left to the 1 index, but I've still seen a W. So now I need to move my left to the 2 index. Now I haven't seen a W. I continue. My max length is 1. So I have left and right are both on the W at line 17. Then my right hand goes to K. We add E, and I get 3. Then I run into that W, I purge the W, and I end up with KEW. It's 3 whether I look at the WKE or the KEW. They're both a solution of 3. I got the right solution. So I think I coded it. Let's check it out. And of course, there's a syntax error because I missed a parenthesis. Welcome to programming. Welcome to programming. Current substring is not defined. See, and this is the blinders of writing it and then even testing. Like, you still need to run the test case. Some interviewers actually don't care about this. That's the crazy thing. At Google, they don't. When I interviewed there and I got an offer there, as I recall, I didn't even run code. I mean, I think I submitted test cases during the code screen, but then during the loop, I didn't even run the code. I just wrote it down and walked through test cases. And so I don't think they would be too bothered. Like, with this implementation, I think a Google interviewer would probably accept it because they know that you just didn't rename the second thing. Whatever, it doesn't matter. But actually the code here is wrong. I still think they would probably let it go. But what I should do here is instead of taking the length of some literal string, because I haven't stored a literal string, what I want to do is right minus left. Right minus left. And that'll give me the current size. So curlen is right minus left. And then curlen goes here. Okay, but the problem is I don't have a right. So I did for this, I need to change this. For, I need to enumerate it, I think is the word. For right in. I'll try to enumerate. This could be wrong. This could be wrong. For right in, enumerate s. And then cur char is right of s. I might need to do a length here, something like that. We'll see. String indices. Okay, so let's do length. I'm forgetting the syntax for the index. Int is not iterable. Yeah, what is the syntax? The good news is interviewers generally let you look up the syntax problem. Because you see what I'm trying to do here, right? I want to convert s to a length. I did that, and then it's just this bit. Been using Copilot too much. Oh, range. For in range. That's what it is. Range. For in range length s. Okay. So it says I got the wrong answer. What happened here? I'm off by 1 in every case. No, here I got it. In my PQ, I got it. So why in the B, I never got it? Right minus left plus 1. So if they're pointed at the same letter, I should still get a 1. No? Do I need to explicitly code an if condition if they're pointed at the same letter? I mean, I could, but it feels wrong. This is that intuition thing, right? It's just because I've done this problem before and I don't recall having an explicit if condition. If right equals left, let it be 1. I can try that out, but I think that's the wrong thing to do. Let's try it out. I think it's the wrong thing to do. So, sometimes it is a new implementation you've never done before and it still works sometimes. So in this case, I think the first for in range, I think right is going to take a value of 0 on the first iteration. Oh, I said if cur char in scene. This is my problem. I need to say while. I need to say while. I'll leave that bit down there, but I think I'm going to adjust that bit as well. So while the current character is in scene. then I'm purging left and I'm updating left. Nope, still wrong. All right, let's try this +1 thing. Cool, all right. We got it. We're rusty, but we got it. What else? We have 10 minutes. Do we have time for one more? What's next? Linked list cycle in 10 minutes. Let's go for it. I don't know. We'll see if we get it. Very different pattern. Oh, very different pattern, but that's the whole point, isn't it? It's an easy problem. It's a very different pattern, but well, there is a hard solution to this. Okay, so look, example 1, 3204. The easy thing to do is to cache this out to a list. You just cache everything to a list, and you go through that list k times, where k is a constant. So I can go through it like 5 times, and it's still going to be O of n time complexity asymptotically, right? And so I go through the list, and then if I see that this is pointing back to an item in my list, I say, oh, I've got a cycle. That is, the time complexity is fine, but the memory complexity is larger than necessary. But if you do that approach, that's the easier approach. The hard thing to do here is to do this with constant memory. You can do this with pointers, with constant memory. Oh, and one of my lives says it's been 57 minutes and the other says it's been 51 minutes. That's weird. I wonder if there's like a lot of lag in my stream. I don't know. We'll do this. If I go a few minutes over, that's fine. It's not a big deal. Oh, darn. I say that, but like the other way with constant memory is a lot harder. So I'm going to time box this to 5 minutes, and I probably won't get it. So approach is fast and slow pointers. Time complexity is O of n. Space is constant. I need to reverse the second half. No, this is to get a palindrome, isn't it? See, I'm just going on autopilot with patterns. That's the wrong thing to do. What do I want to do here? Oh, I just need fast and slow pointers. I think the whole spiel I just said about like doing it in constant memory is hard. I think that's not true for this problem. I think that's hard for palindrome, linked list palindrome, which would be the next one. Okay, we're not going to do that, so I can skip it. I just need fast and slow pointers here. If they ever collide, there's a loop. If they ever collide, there's a loop. Approaches fast and slow pointers, time complexity is O1, space is constant. That's all true. So here, fast is, they'll go by index, and then slow is 0. So I'll say while fast is less than length. Oh, right, I'm using a linked list. So I'll say while, so fast is head and slow is head. And I'll still say while fast. While I have a non-null pointer. So once fast goes past the end of the list, there won't be a cycle because the thing ends. So there can't be a cycle. Does that make sense? I think I'm rushing a little bit, chat, so if my explanation didn't make sense, just drop a comment and I'll repeat myself. So while I have a fast pointer, fast will move twice. And this is a short-circuiting operator. So if fast.next is null, it will set it to null and it won't execute the second hand of the expression. Okay? But slow is just slow.next. It's only going to increment one. It's only going to increment by one position at each iteration. That's why it's slow. And then I'll say if fast is slow, return true, else return sheesh. If I get out of the loop, return false. I think that's the whole thing, huh? Wrong answer. Wrong answer. So why? I returned true. Why did I return true? I returned true because fast short-circuited, and the short circuit pointer yeah. So they were both pointing at none. And that's the reason that I returned true. So this, I just quickly added fast and to get rid of that case. I think this should work. But there's another way to do this. I think I could say like while fast and fast.next. I think that's another way to do it. So that worked fine. Say while fast and fast.next. And I think this would also work without the compound if condition. Oh, and then I missed my colon. Rushing, eh? Cool. So those both work. It looks like this one's a lot slower. I wonder if that's just random variation. So beats 70%. Let's submit it a couple more times and see if it's just random variation. There could be a logical reason why this, yeah, and now it beats 92 or something. So it's in the 70 to 92 range. Let's look at the other. $70 to $92 versus I think the other one was around 90, and then now it's down by 6. Yeah, so the performance is equivalent. Cool. That's going to do it for the current stream. Thanks so much for being here. Again, my name's John. I am the lead maintainer of Latterly.io, which is an educational platform that will help you land your first or next programming role. It's beginner friendly. I hope this didn't freak you out too much. If you go through this checklist, am I logged in? I'm logged in, yeah. So you can sign up for free. You go to this checklist. Leetcode is like down by step 20. It's very beginner friendly. You don't need to like dive into that stuff. If you're like, I've never seen code before, linked lists freak me out. You can watch this video, step 3. That's called. And in an hour and a half, it'll get you comfortable with like the basics of coding. You only need to get into Leetcode optionally, recommended, but optionally, after you've built a few projects. By the time you've built a few projects, you're going to be comfortable with code. And so it's true. You get comfortable with coding, like the normal way to build websites and stuff, and then you separately practice the job search and interview skills, and it's a different skill set. But by the time you build a portfolio of projects, you're going to be ready for that next step. So don't be intimidated by the Leetcode, even if you're early career or new to coding or new to Leetcode. We'll take care of you. You can join the community, join the Discord. That's also the first thing in the checklist, so you don't need to go it alone. One of the mistakes I see with career switchers is trying to silo themselves, be really independent. I'm so strong, I'm so good. That's not the way to grow your network, grow your job opportunities, grow your career. You could do it. I mean, it's true. Like, there's something like 5% of people that can just take a series of YouTube videos and just start coding and get a job. For most people, it doesn't work. For about 5% of people, it does work. But even for those people who can do it, it's still not optimal. You're still going to get more job opportunities, a bigger network, faster career acceleration. So even if you can go it alone, it's just not a good idea. So hope to see you there.